This is PreCalculus 12, chapter 4.2. We're going to be looking at combining functions algebraically this time. So the big concepts. When you're adding and subtracting, it's going to behave like the most dominant term. So if we have these two functions, x cubed grows the fastest. It's going to behave like a cubic function. If we're multiplying, the product of the dominant terms will behave like x cubed times x squared, so that's x to the fifth, a quintic function. If we're dividing, it's going to behave like the quotient of the dominant terms, so x cubed divided by x squared, and that's just x. And it's going to have other things like rational functions, so it's going to have wholes or vertical asymptotes. You should have learned some function notation before, but let's recap. This is the function name. Or letter. We don't always use F. We can have other letters too, and you should get used to it. You've seen function names before. This would be sine, cosine, absolute value. It's just for absolute value, we don't use letters. We use the vertical lines. However, if you're using it on a calculator, most calculators will say ABS. This is the parameter. It's also called argument, and it's the input from the domain of the function. Okay, this could be x, it could be y, it could be z, it could be theta, it could be r. And this equals the result or value or answer, and it's the output from the range. Okay, so let's just practice by evaluating functions. Now, we're using our f of x here. So negative 6 to the power of 4 plus negative 6 to the power of 3 plus square root negative bracket negative 6 minus 5. Okay, and the note here, always substitute with brackets. I think I've mentioned this before. Okay, and I purposely made negative signs in here to make it more challenging. So here, you just plug it into the calculator, that's 1296. This negative sign gets cubed, so we have minus 216. And this negative negative becomes positive, so it's plus square root 6 minus 5. And we can simplify this to 1075 plus root 6. Should always collect like terms. Here's another example. You can substitute an expression. So 4 minus 7 raised to the power of 4 plus 4 minus 7 raised to the power of 3 plus square root negative 4 minus 7 minus 5. Again, we expand the powers. We get 81 minus 27 plus square root 3. This is negative 3. Take the negative of that, it becomes positive. And this simplifies by collecting like terms. We get 49 plus root 3. So you may not have seen this before, but we can substitute an expression with variables. So this is y squared minus 5 to the power of 4 plus y squared minus 5 to the power of 3 plus square root negative y squared minus 5 and minus 5. There's not much to simplify here, but we should do it anyways. And we distribute this and we get 5 minus y squared minus 5. And a reminder, use the most restrictive domain if you're asked to find the domain. And you should always check to see if powers need to be expanded into standard form. Okay, let's look at some algebraic problems. So we have, again, h of x equals f of x plus g of x. There's a shorthand for this. We can put brackets around f plus g and then put brackets around the parameter. So this is alternate. You are free to use either one, but sometimes this will be shorter to write. Okay, so if we have f of x equals x cubed plus x, g of x equals x squared plus square root x, domain is all reals for f, the range is all reals for f because it's odd degree polynomial. Domain for g is slightly more complicated because we have square root. So it's x greater than or equals 0. The range of g is y is greater than or equals 0. So h of x, we just collect like terms. X cubed plus x squared plus x plus square root x, and we write it in order. We order the polynomial. This is a special case. For calculating the range. Okay, because we have all positive terms. So that makes it easy. Because we're starting from 0, we take the most restrictive domain. 0, 0, 0, 0, we get 0 as an answer. And we only get bigger values because they're all positive. So the domain of h is x greater than or equal to 0. The range of h is y is greater than or equal to 0. Okay, let's look at subtracting. Again, we have a shorthand for this, f minus g in brackets and x in brackets. And we can just write it out in order. There's no tricks here. X cubed minus x squared plus x minus square root x. We can figure out the domain. That's x is greater than or equal to 0. And this is a little bit trickier because we have plus and minus. Now, like I said, the range is going to behave like the most dominant term. So this is going to go to positive infinity. So it's going to be greater than, y is greater than something. And you're not going to get it algebraically, so you have to use a calculator. And we find that the min is negative 0.333. So 0.333. And the reason is because x cubed, positive x cubed dominates. Find min. Okay, multiplying. Again, we have the same shortcut, bracket f times g, bracket, and x in brackets. So we have x cubed plus x times x squared plus root x. And we need to expand this, x to the fifth. And the next biggest term is going to be this times this. This is x cubed times square root x. The power of square root x is a half. So this is actually 7 over 2. And then this is x cubed. And we have plus x. 1/2 plus 1 is 3 over 2. Okay, again, all positive terms. So we can calculate the range precisely. Domain of h, x is greater than or equal to 0. We have this restriction, so we've got to follow that restriction. The range of h. So if we plug in 0, that's our end point. That's where we start. And as we make x bigger, we get all the values bigger than 0. Dividing. We have x cubed plus x over x squared plus root x. We have x equals 0 is our NPV. Again, we have all terms positive. So domain of h, x is greater than or equal to 0. Okay, so we do have a common factor here that cancels out, and that's root x. So we can factor out a root x out of everything. That means we do have a hole at 0. And since we have a hole at 0, that means y is greater than 0. And we could try to graph this to figure this out. So we need to have brackets. Around the numerator and denominator. And graph. And if I try to solve for a minimum, it's going to say none found. Okay? If we look at this, it's going towards 0. And because it's going towards 0 and there's a hole, there's no minimum. We can just keep getting closer and closer to 0. So it approaches 0, but it's not equal to 0. So we have to say it's greater than 0. Next, we have to find functions. And usually there's many solutions, but you need to pick easy ones, but not trivial. And I'll explain this in a bit. Okay, so we have a k of x. We need to find an f, a g, and an h such that f of x plus g of x minus h of x equals k of x. So we can pick relatively easy ones. This is positive, so we'll make it x to the power of 4. G of x is a plus, so we can just use plus negative. And then for h of x, we need to subtract this, so we need to make it negative 2x squared minus 10. So we just flip the signs here for negative. We could have also done a different answer. G of x equals, we're adding these two, so 2x squared plus 10, and h of x, because this is subtraction, we can just use the positive version of that, 3x cubed. So again, these are easy, but not trivial. Trivial would have been f of x equals k of x. I don't want to copy the whole thing, but if we make that and we just make g of x equal to 0, we make h of x equal to 0. This is trivial. We're adding 0. So really, that function doesn't exist. Okay, let's look at another one. H of x equals x squared minus 5x plus 6. Find f and g such that h of x equals f of x times g of x. And the only way to get an f and a g that's not trivial is to factor. Must factor. So we have equals x, x. Because this is positive, we need the same sign for both terms, and it's going to be negative. And the factors of 6 that add up to 5 are 2 and 3. So f of x equals, it doesn't matter which one you pick, x minus 2, and then g of x is going to be the other one, x minus 3. So there's a limited number of ways to create this that's not trivial. And last, h of x equals x cubed. Find an f and g such that f of x over g of x equals h of x. And we need to be careful about the domain. We could write f of x equals 3x cubed and g of x equals 3, but this is trivial. And it's trivial because there's no x. There's no variable in this function. And a better answer would be this. But it doesn't work. Because x equals 0 is an NPV, and that's changing the original domain. We want a g of x that is not factorable. So I'm not going to give you the answer, just see homework. And again, avoid trivial solutions because you will lose marks. Don't pick f of x or g of x equal to 0 for addition and subtraction. And don't pick f of x equals c or g of x equals c for multiplication or division. Okay, so that's just a constant term. Constant term. No variable in function. And that completes this lesson.